continuing our conversation related to the time value of money, I want you to make you aware that there is a template, an Excel template called Time Value Money Practice that you should have opened at this point, so that as I explain certain concepts and go and solve problems, you should be able to refer to this Excel sheet because this is the one that we're going to be using for problem solving. Okay, but the presentation itself is a continuation of the introduction that we shared concerning time value of money. In the previous video, we found the future value. Now I'd like to propose to you that if we know the future value of any investment, remember we were using the same formula that we used previously. Let me just emphasize this right here. Okay. We can change the nomenclature just a bit and say that and recognize the following. This investment that we made up front, that investment is an investment made today in the present. So the future value formula that we explained previously can be re-expressed as just the future value at any point in time, right? The future value at time period n, whatever that may be in the future, is going to be a function of the amount that we invest today, the present value today, multiplied times 1 plus the interest rate raised to the number of periods. Okay, and the reason why this is important is because now we can ask ourselves not what is the future value of the investment today, but we can ask ourselves, what does an investment or a payment or an investment in the future, what is that worth to us today? And this is so important because then that's when we are able to make investment decisions, right? When we are able to compare the investments we make today with the values today of those future expected payments. Okay, so let me just give you a numerical example that would hopefully help clear things up. So remember now, the present value of any future amount located at any point in time, n, is going to be converted to its present value equivalent by dividing it by 1 plus the rate of return that we want to earn, right? In some references you will see them as I. In our text, you're going to see it as R. I want you to be aware that the two are basically coexistent. In other words, both are used, right? I'm going to continue to use R because of the textbook, but just be aware that you may find I in other references. So don't worry, it's just the same thing. It's always the interest rate that you expect to earn. Okay, so let's suppose that right now you promised two payments, $100,000 in year one and $200,000 in year two. Now, how much is this investment opportunity worth to you today, knowing that you could otherwise earn 9% on any investment similar to that? So think of it this way: your opportunity cost of capital is 9%, right? Any money that you invest could otherwise be out there earning 9%. So if you were promised $100,000 in year one, this is future values, right? A future value in year one and a future value in year two. How much are those worth to you today? And remember, don't forget that the present value of any investment is just a future value, right? Discounted or divided by 1 plus the discount rate, right? R and N, right? So if here we have a situation where you have $100,000 located in year one and $200,000 located in year two, then what is the value today of those two future amounts? All we have to do is take the first $100,000 and do what? And just discount them, bring them back, convert them to times zero value. Okay, that's what we're going to do. Then we're going to take the $200,000 and discount them back 2 periods and find its present value, its value today at time zero. And then we're going to add those two up, and the sum of those two present values is going to be what those two promise payments are worth. So if you're thinking about an investment that will give you $100,000 in year one and $200,000 in year two, the question is, how much would you be willing to pay for that investment? And the answer is whatever is the present value of those two amounts. So let's find the present value for the first $100,000. That's done right here, right? Because the $100,000 are located one period into the future. You just divide it by 1 plus your opportunity cost of capital, the 9% raised to the first power. The $200,000, because they're located 2 years into the future, you're going to divide it or discount it by 1 plus the 9% raised to the second power. If the $200,000 had been in year 3, then you would have had to divide or discount the $200,000 by something raised to the third power. Okay? The point is that the present value of these two, that value is worth $260,000. What does that mean? It means that you will be economically indifferent between two scenarios. Scenario 1, a scenario in which you receive $100,000 in year 1 and $200,000 in year 2. Or scenario number 2, a scenario in which you receive the $260,000 today. So receiving $260,000 today and then leaving it there, earning 9% for 2 years, is economically equivalent to instead receiving $100,000 in year 1 and $200,000 in year 2. Okay. Some of you may wonder, wait a minute, isn't $100,000 and $200,000 equal to 300? No, you cannot add them because you're not adding apples and apples. The first $100,000 are located at the end of year 1, while the $200,000 are located at the end of year 2. As we agreed beforehand, there's a time value of money component, right? A dollar today is not worth the same as a dollar tomorrow. $100,000 have to be treated differently than the $200,000, not only because the amounts are different, but because they're located at different points in time. So you can't just add $100,000 and $200,000 together and say, oh, this is $300,000. How can you say it's worth $260,000 today? No, you cannot add those two. The only way you can add numbers is that they're both located at the same point in time. This is why we discounted the first $100,000 back to 0 and the $200,000 back to 0 and added a 2. The sum of those two is $260,000. If you don't believe me, just take the $260,000 today, make it earn 9% for 1 year, pay yourself $100,000, and then whatever's left in that account, make it earn 9% the second year, and you'll see that you will also have enough money to pay yourself the $200,000. In other words, receiving $260,000 today is the same thing as receiving $100,000 and $200,000 in years 1 and 2 respectively. So here's the answer to an investment question. If I promise you $100,000 in year 1 and $200,000 in year 2, and I'm asking you to pay me $280,000 for that right, would you accept? And the answer would be no, you will not accept, because to you, those promised payments are worth $260,000, and I'm asking you to pay $280,000. So if you were to pay $280,000 for these two promised payments, you will be overpaying.